Hi students. So the problem number 9. In the given figure of a voltage regulator, a Zener diode of breakdown voltage 10 volt is employed. Determine the current through the load resistance, the total current and the current through the diode. So first you must see that there are two resistors and one Zener diode, and there is a battery of 25 volt. This circuit only is a voltage regulator. We very well know that one of the very important applications of the Zener diode is what? Voltage regulator. So irrespective of the variations in the current, Zener current or the load current, the load voltage or the Zener voltage will remain constant. So in this circuit, the given value is Zener voltage, the Zener voltage Vz, which is also equal to the voltage across the load voltage, that is given as 10 volt. So this is the given information. From this, first we are going to determine the current passing through the load resistance. You can see here, the battery of 25 volt is sending a main current. The main current in the circuit is I ampere. So I ampere current is flowing through this source resistance or the drain resistance, input resistance. Rs is equal to 500 ohm. Then at this junction, this I ampere current is dividing in how many paths? There are two ways, two paths. So along the load resistance, through the load resistance, the current is IL, and the remaining current passing through the Zener diode is IZ. So by Kirchhoff's law, this I must be equal to what? IL plus IZ. So using all these information, let us begin with the load resistance. Okay, Vz, this is equal to 10 volt. It is given as 10 volt. So the potential drop across this resistor is also equal to how much? 10 volt. What current is flowing through the load resistance is IL. So IL, okay, IL into RL must be equal to VL, that is equal to 10 volt. Therefore, what is IL is equal to this 10 divided by RL, load resistance. So what is the RL value they are given is 3 kilo ohm, 3 into 1000, okay. So this is equal to 10 divided by 3000, 3 kilo ohm. So this is also equal to what? 1 by 300. So this is this can also be written as 10 by 3 or 10 by 3 into this 10 power minus 3. It is up to you. Mathematical calculation you can do anyway. 1 by 3 also you can take. So 10 by 3 means 3.33. Understand? Therefore, IL is equal to 3.33 into 10 power minus 3. Therefore, I will take a milliampere. So this is the load current, that is equal to 3.33 milliampere. Have you understood the first step? Okay. So the first information is determine the current through the load resistance we have found. Okay. Next, the total current in the circuit is what? I. Is it not? So this I is the current sent by the battery 25 volt. So when the current is flowing through this resistance of 500 ohm, a potential difference will be dropped across the resistance. And the circuit, if you take this closed loop, first loop with this Zener diode, there is an opposing voltage of 10 volt. Because it is a reverse bias diode, is it not? So there is an opposing voltage of 10 volt. So out of the 25 volt, if you subtract this 10 volt, the remaining only will be the potential drop across the resistance. So 25 minus 10, here the potential drop must be equal to what? 15 volt. Okay. So the product I into RS must be equal to 25 volt minus 10 volt. So I into RS. So I into 500 ohm. RS is what? 500. So I into 500 is equal to 25 minus 10, that is 15. Therefore, the total current I must be equal to what? 15 divided by 500. So this can be written as 15. 5 3s are 15. So this is 3 divided by 100. Therefore, I is equal to 3 divided by 100 is 0.03. Okay, ampere. 0.03 ampere. Okay, so this also can be written as this also in milliampere if you want. See, I can also express this in milliampere. This also equal to 0.03 into 10 power 3 milliampere. So I is again written as what? 30 milliampere. Because the previous value IL I have written in milliampere, so I wish to express this also in milliampere. Okay, so I multiply by 10 power 3 and divide by 10 power 3 so that it will become milliampere. So I also is now equal to 30 milliampere. Have you understood, children? So 2 steps we have completed. Finally, what we have to find is the current through the diode. So I already said at this junction we are going to apply Kirchhoff's current law. Okay, so applying Kirchhoff's current law, the total current I is equal to Zener current plus the load current. So we have now the values of the load current IL and the main current, total current I. Therefore, what is IZ equal to? I will write here. Therefore, IZ is equal to main current minus the load current. So IZ is now equal to, total current is 30 milliampere. So this is 30 minus here 3.33. So this is 3.33. The unit is milliampere. So 30 minus 3.33 if you find out means it must be equal to 26.67 milliampere. Okay. Therefore, the Zener current IZ is equal to 26.67 milliampere. So if I add this with the load current, it must be equal to the total current. Okay, children, have you all understood? Okay, I hope you must have understood well. Fine.